Welcome AP Bio students. Today I'm going to work through booklet pages 24 and 25 on sex-linked problems and go over how you solve these problems. So I'm going to get right into it. I've got 8 questions to do. I'm hoping to get this done in under 10 minutes. I don't want this video to be too long. So number 1, show the result of a normal man marrying a colorblind lady. Like always, you have to create a legend. When it's a sex-linked trait, that means that the allele is found on the X chromosome, so your legend has to show the X chromosome. And it's written as a superscript. So we know that being colorblind is a recessive sex-linked disease. So having a capital letter means you have normal vision, and X lowercase b means you are colorblind. I picked letter B just arbitrarily. Whatever letter it is doesn't matter. B is a good letter. So a normal man means he's not colorblind, crossed with a colorblind lady, X little b, X little b. You set up your Punnett square just like always. You've got your gametes for the male in whichever order. You've got your gametes for the female in whichever order, although in this case they're the same. You do your cross, X, B, Y, X little b, Y, X big B, X little b, X big B, X little b. And then you show your phenotypic ratios, which I've pre-created. Oh, can you read those? Put that up there. Phenotypic ratios, you can write this out in 2 ways like I talked about in my other podcasting. Phenotypic ratio, you can show it as the whole Punnett square. So 2 out of 4 are carrier females and 2 out of 4 are colorblind males. Or you can show it where you break it down by sex. And that's the way I prefer, but it doesn't really matter. In this case, I'm talking about my females. 2 out of 2 are carriers. Males, 2 out of 2 are colorblind. Just to review, a carrier is somebody that does not have the disease or condition, in this case colorblindness, but carries the allele for it, which means they can pass it on. So that's a carrier. Okay, let's quickly move on to the second question. What would happen if a colorblind man married a carrier lady? So I don't have to redo my legend. We'll just quickly write out a colorblind man marries a carrier lady. I'm going to try to go fast here. X, B, Y. Oh, didn't leave myself a lot of room up here. There's my Punnett square, and then there's the phenotypic ratios done in the 2 different formats. I'm going to go quickly on to the next one, but you can obviously pause the video if you need to look over these phenotypic ratios. I'm trying to go a little faster here. So question number 3, show the cross between a colorblind man and a colorblind lady. Colorblind man, colorblind lady means she has to be homozygous recessive on both X's. Punnett square. Oh, that got messy. Quickly fertilize. And then we have the phenotypic ratios. So again, pause the video if you need to look this over with a little bit more time. Question number 4. Normal man married a lady who is a carrier. A normal man marries a carrier lady. Punnett square. And phenotypic ratio. I've done it just in the female-male way this time. Next question. Now we're getting a little bit more complex because we're now doing dihybrid questions. What would be the result of a heterozygous curly-haired man? It says later on straight hair is recessive. So I have to do a legend again. This is not a sex-linked trait. A big H for curly hair, a little h for straight hair. Tells me up here straight hair is recessive, which means curly hair is obviously dominant. Then we've got the color blindness again. That is sex-linked, so we set that up. There's my legend. So we have a heterozygous curly-haired man, so big H, little h, who was colorblind, married a straight-haired lady. We know straight hair. Whoops, that's a mistake. Straight hair is recessive. Little h, little h. with homozygous normal. X big B, X big B. Now we have to set up the gametes. Here's where it gets a little bit trickier. Big H with X little b, big HY, little h X little b, little HY. That was for the male. Female is a little bit easier. They can only make one type of gamete. Sorry, I kind of got small there. And now we have to fertilize. H, X, big B, X, little b, big, little, X, big B, Y, little, X, big B, X, little, X, big B, Y. There's my Punnett square. Oh, sorry, I dropped something, so I can't move this. There we go. And there's the phenotypic ratios. Hopefully you can see that. Trying to go quickly. Number 6, show the result of a homozygous curly-haired normal vision man. So, same legend as last time. Homozygous curly-haired normal vision. Crossed with heterozygous curly-haired colorblind lady. There's the 2 possible gametes for the male. There's the 2 possible gametes for the female. So we know that if it's a 2 gametes times 2 gametes, we're going to have a 4-box Punnett square. Fertilizing. And phenotypic ratio. You can read that. Next one's a little bit different because you don't have to do a Punnett square here. We have 2 brown-eyed normal vision parents. So we have 2 brown-eyed, brown eyes is dominant, blue eyes is recessive, plus the normal X-linked vision stuff for color blindness. So we've got brown-eyed normal vision parents. So there's the dad. And we don't quite know just yet. They produced a blue-eyed colorblind child. So a blue-eyed child had to be that. And if they're colorblind, they must have at least one lowercase b on their X chromosome. Well, the dad did not have a lowercase b, which means the mom must have had the lowercase b. The second gamete for the child has to be a Y then, because if it was an X with a big B, they wouldn't be colorblind. So based on this, we know that had to be heterozygous. That had to be heterozygous in order for the kid to be blue-eyed. And the mom must have been heterozygous for colorblindness. To get this kid, that had to be the genotypes of the parents. The sex of the child then, of course, had to be a boy. The only way you could get this result was if you had a boy with the parents that are with the genotype shown. Last question. What would be the result of a blonde man with hemophilia? So we know that hemophilia is a sex-linked trait, a recessive sex-linked trait. So lowercase h on the X chromosome is a hemophiliac. Just go hemo. So we've got the cross there. We've got the male. Of course, we've got brown hair still. Big B, little b for blonde. I don't think I actually said that on here, but brown hair is dominant, blonde hair is recessive. So the dad, little b, X, little h, Y, and the mom is heterozygous and heterozygous for hemophilia. She's a carrier for hemophilia. This is a much tougher Punnett square. This is the big one. There's the possible gametes for dad. Sorry, that got messy again. Just for brevity's sake, I won't fill that box in. You can do that on your own. And there, where can I put that so you can read it? There's the possible phenotypic ratios for this cross. This one got complicated. Anyway, I'll shut this down. It's got long enough already. I will post the answers for booklet page for the rest of the booklet, sex-linked traits, tomorrow. Talk to you later. Bye.